Soil classification. Textural classification. In a general sense, a texture of soil refers to its surface appearance. Soil texture is influenced by the size of the individual particles present in it. A number of textural classification systems were developed in the past by the different organizations to serve their needs, and several of those are in use today. And one is the textural classification system developed by the U.S. Department of Agriculture, more known as USDA. This classification method is based on the particle size limits as described under the USDA system in Table 2.3. That is, for sand, the particle size are from 2.0 to 0.05 millimeter in diameter. For silt size, that is 0.05 to 0.002 millimeter in diameter. And for clay size, this is smaller than 0.002 millimeter in diameter. So under the USDA, US Department of Agriculture, we use the textural classification chart. So this is the textural classification chart of USDA. Notice that on the x-axis you have the percentage of sand, and then on this side you have the percentage of silt, and then on this side you have the percentage of clay. So all we have to do is to plot the percentages of the sand, the silt, and the clay, and then to where it intersects, you can see here the different textural classification. If it is clay, if it is sandy clay, if it is clay loam soil, silty clay loam, and the other textural classification. So this is the chart that are being used if we are classifying the soil based on their texture or textural classification. So to further understand, we will try to identify the classifications of soil A, B, C, and D. So on the given, we have the soil A, B, C, and D, but we will only plot soil A and soil C for demonstration purposes. So for soil A, the sand is 22.2%, the silt is 45.6%, and the clay is 32.2%. So using the USDA textural classification, we are to plot and then we are to classify if what is the textural classification of this soil A. So note that this is soil A. So let me just write. This is soil A. So how are we going to plot? If we are going to plot sand, we simply find the percentage of sand, which is here. So notice the extended lines. This will be our guide. So if we are plotting for sand, this will be our guide, meaning to say our direction would be towards the direction of this extended line. If we are plotting for silt, that is downwards. So we follow the direction of these extended lines. And then for percentage of clay, that is horizontal lines, we follow the direction. Right? So let's begin with sand is 22.2%. So sand is somewhere here, 20, 30. So 22.2 is somewhere here. So following the direction of this extended line. Okay, so that is 22.2%. Next is we plot for silt. Silt is 45.6. So percent silt is somewhere here, and that is 45. So 10, 20, 30, 40, and 50. 45.6 is somewhere here. This is linear, so you can plot it easily. So 45.6. And then clay is 32.2. We have here our clay. And then 10, 20, 30, 40, 32 is somewhere here. Okay, so kung saan nag-intersect yung tatlong line, that will be the classification of the soil. So for this is clay loam soil. The classification is clay loam soil. Next is soil C. Let's consider soil C. So for sand, that is 18%. Again, our sand is somewhere here. And then 18, this is 10 and 20. So 18 must be somewhere here. So that is percent sand. Next is to plot for the percent silt. Our silt is here. So 24, 10, 20, 30, 24 is somewhere. And then next is the clay, 58%. So 50, 60, follow the direction of the extended line. So kung saan sila nag-intersect, that will be the classification of the soil. So soil C is classified as clay. So note that the chart is based only on the fraction of soil that passes through the number 10 sieve. Hence, if the particle size distribution of a soil is such that a certain percentage of the soil particle is larger than 2 millimeter in diameter, a correction will be necessary. So if there are particles greater than 2 millimeter, there is the presence of gravel. We have the presence of gravel. So we have to modify the percent of sand, the percent of silt, and the percent of clay using this equation. So say for example, modified percent of sand is equal to the percent sand divided by 100 minus the percent gravel times 100. Modified percent of silt is percent of silt divided by 100 minus percent gravel times 100. And then modified percent of clay is equal to percent clay divided by 100 minus percent gravel times 100%. So example, so we have here another soil. Let's name this as soil. Say this is soil E. So this is soil E. So soil E has the following component. Gravel is 20%, sand is 40%, silt is 22%, clay is 18% for a total of 100%. So notice that in the chart we don't have percent gravel, right? So we only have the clay, we only have the sand, and we only have the silt. There is no gravel. So that's what that is why we have to modify it. So to modify it, we have to use this equation. So let's modify percent sand. Modified percent of sand is our percent sand is 40 divided by 100 minus percent gravel. Our gravel is 20%, so minus 20 times 100. So the modified percent of sand is 50%. Next, modified percent of silt. So percent silt is 22 divided by 100 minus percent gravel, which is 20 times 100 is equal to 27.5%. Next, modified percent of clay. Our percent clay is 18 divided by 100 minus percent gravel, which is 20%. The quantity times 100, so this is 22.5%. So this is now what we are going to plot on the chart, on the USDA chart. So percent sand is 50%. Percent silt is 27.5. And then we have the percent clay, which is 22.5. Okay, so again, where the three lines intersect, that will be the classification of the soil. On our case, the three lines intersect on a boundary. Okay, so notice this one. This is a boundary between sandy clay loam and loam. So therefore, the classification of the soil is gravelly sandy clay loam or gravelly loam. So take note of the word gravelly. So we add the word gravelly whenever the percentage of the sand, silt, and clay are modified.